AgrarSense. Smart, digitalized components and systems for data-based agriculture and forestry is a Horizon Europe project that tackles an array of problems of our time. Climate change, supply chain issues and labor shortages all threaten food security. Through a joint undertaking, the AgrarSense consortium of 57 partners plans to take agricultural technology and productivity to the next level. Vertical farms can be one solution for these issues. But with this new technology, new challenges arise, something that Use Case 2, vertical farming, tackles. The goal of the consortium is to increase efficiency through scalability while at the same time increasing product quality. The consortium consists of the lead Smart Greenery, Research Studios Austria Studio SDIS, Microfluidic Chip Shop, the Swiss Center for Electronics and Microtechnology, CISC Semiconductors and Soil Scout.
In our use case with Smart Greenery, we are working on vertical farming. Vertical farming is being used here to produce plants which are being used in medicinal products later on. And it's very important to optimize the growing conditions in this artificial environment based on sensor readings, for which we are using some autonomous management control loops. We are also investigating the scalability of these control loop approaches.
Especially in a vertical farm, a wrong parameter setup or a not detected malfunction can destroy a full plant generation. An equally important requirement is maximum efficiency in operation concerning energy, water, and fertilizer use. Main cost drivers are energy costs for the growing lights. So optimizing the energy flow and energy recovery between interconnected vertical farm modules thus gives an additional possibility to reduce production costs. A trouble-free and secure operation using reliable technologies that are continuously monitored in order to be able to react very quickly in the event of malfunctions supported by AI. Due to the enormous amount of operational data collected and its transmission to cloud storage, protection against cyber attacks and protection of personal data is another important requirement.
The challenges are the high energy consumption in a vertical farm, the complexity in production, and also the intensive culture of plants. So we try in AgrarSense to work out these problems and to find solutions that a vertical farm gets more efficient.
To sum it up, Use Case 2 wants to reduce fertilizer, water and CO2, reduce the growing process losses to less than 1%, increase energy savings up to 30%, and increase lighting power savings up to 30%. The project lead Smart Greenery focuses on the LED architecture to save energy. They built a test farm with 12 LED grow lamps, and after the successful integration of the sensors, the efficiency of the test farms can be put to the test.
So here in the AgrarSense project, we from Research Studios Austria are planning to collect all the sensor data and then put it into a machine learning algorithm. And the machine learning algorithm then learns on how to automatically and optimally control the farm, like the lighting setting, the irrigation system, temperature and humidity.
So we are just setting up the farm for the next test run. Here you can see we just put in the plants. You can see how the plants get their water. Here for this we already have a full tray, and this tray is already fully installed with the water connected to the plant trays. And here you can also see the sensor from our partner Soil Scout. It's fully wireless and it lives up to 20 years, and you can track in real time temperature, salinity and moisture.
We from CISC Semiconductor provide a solution to track the plants during the production. We use UHF RFID with such kind of tags. We have a two-phase approach. First of all, the compartment where the plants are growing are tracked. That means during the production we can track the movement of the compartment, so we will see if the plant is moved out of the farm and new plants are put into the farm. And the second approach is we use special tags which are able to measure temperature and humidity. The idea is if the plant is harvested and put into a plastic bag, there are the two tags measuring the temperature and humidity, so that we know the environment of the plant when the harvested plant is frozen or afterwards given to the delivery to the customers.
We are working on the project on several use cases, in particular use case 2 here for the vertical farming, and we are contributing in the multispectral imaging for pest detection. And during the project we developed first multispectral imaging devices like this to do some early data acquisition to really extract the spectrum of the pests like thrips, spider mites and so on. At a later stage that we just are starting implementing, we just switched to a regular camera like this one, and we make the illumination of the panels, the LED panels that we see here vary so that we can increase the contrast and see the presence of pests or not.
So this is a microfluidic device, and this is usually used for capillary electrophoresis to measure the annelids. In this project we are doing the fertilizer optimization with this device, and this device will be used for measuring nitrogen, phosphate, potassium, calcium, magnesium and sulfur mostly, because that's the project need, and this will be helpful in reducing the fertilizer usage as well as protecting plants from getting overdosed.
The integration workshop was a great success. All the partners from all over Europe came and we integrated the sensors together. And now the interesting part for RSA starts. Now we get all the data and now we can gather all the information and start training our machine learning models.
So the next part is also to do security assessment in our project. So we already gathered all the information from all our partners, and we will now put it all into a threat model and then also do security assessment and also see how safe our systems are and even try to improve them to make them more safe.
Very proud as Smart Greenery to take part in this very interesting EU-supported project with our self-developed vertical farming. And we are convinced after this 3 years project that we have a lot of new skills and new instruments to be successful on the European market with our vertical farming.